All right, welcome everybody. First I have to thank our sponsors before I forget. JetBrains is giving us a free license for a year. There will be a raffle later on, and there are stickers over there. GoBridge is sponsoring the Go Meetups, and yeah, Speechmatics is doing the pizza today and the location. So we still need speakers for the next talk. So if people are interested, please let me know. If you want to host it yourself as well somewhere, please let me know. We're fine with that. And yeah, I'll now give over to the speaker of today, which is Ray Miller, who's going to be talking about Prometheus.
Okay, I'm going to speak sitting down so that I'm not moving around too much for the camera. So my name's Ray Miller. I work as a DevOps engineer at a startup in Cambridge called Metail. Metail are not big users of Go. The only Go we have is some systems utilities that I've written and a few Prometheus utilities I've written. But we do use Prometheus. And I'm happy to attempt to answer questions about both Prometheus and Go. I'm happy to be interrupted anytime. If you do have questions, if anything's not clear, just ask. If I'm spending too long on something, just yawn and I'll take the hint and try to move on a bit more quickly. So what we're going to try to cover this evening is some motivation of why do we want metrics from our Go programs, a look at Prometheus itself, a slightly deeper look at the Prometheus data model, and then probably about halfway through the talk we get on to some code and start looking at the Go client for Prometheus. And it's mostly example driven. Red we'll come on to is a set of metrics that are interesting, and then we'll sort of round off by looking at how to instrument an HTTP handler, because everybody's writing web servers and web services these days. Okay. So, before we get on to that, I'm wondering how many people in here already know about Prometheus, or anybody already using Prometheus? So we have a few. Has everybody heard of it? Okay. So, and then how many people using Go? Okay, most of you. Good. Okay, so sort of what's the motivation here? Why collect metrics from our Go programs, and what sort of metrics do we want to collect? So one reason is for analyzing long-term trends. So how is the behavior of our application changing over time? Can we predict when we're going to need additional capacity? So I've got comparing groups or comparing over time. So has the way our application's behaving changed over time? Has it changed since last week? Are we seeing more errors than we were last week? Comparing groups, if you're doing something like canary deployments, you might have a group of servers that are running a different version of your software, and you might want to compare, is that serving requests as quickly? Is it doing better? Is it generating statistically significantly more errors? You want to know when there are problems with your service, so you might want to alert on certain conditions, like your service is down is an obvious thing to want to alert on. You might want to build dashboards so you can show people how wonderful you are. You might want to collect statistics for debugging. The sort of things that are useful for debugging are things like in a Go program, memory usage, how hard the garbage collector is working, how many open file descriptors do you have, looking for memory leaks, file descriptor leaks, Go routine leaks. So some things like, is my service up, you can monitor from outside with some sort of black box monitoring, just pinging the server. But other things like how many Go routines are currently running are quite difficult to monitor from outside. You might have sort of a queue and worker model in your application. How big is the internal queue? That's something else you're not able to monitor easily with black box monitoring. So I've sort of in my head there in the debugging, and then predicting future needs. How soon are we going to have to throw more hardware at the problem, or more memory, or whatever? Okay, so that's the why. These 4 golden signals are straight from the Google SRE book, and these are the sort of things that it might be interesting to measure about an application. So how long is it taking to serve requests? How much traffic is our service currently seeing? How busy are we right now? What proportion of requests are failing? And how full is the service? That's saturation. How you measure saturation depends on what your service is doing. If you're doing a lot of disk I/O, and disk I/O is the limiting factor of your app, then disk I/O is the thing to measure saturation. If you're handling HTTP requests, and you've got a separate Go routine for each request, are you running out of Go routines? Are you able to handle all the requests that are coming in? Network bandwidth's another thing you might want to be measuring. They're what we might want to measure. So what is Prometheus? Prometheus is an open source monitoring tool. Coincidentally, it's written in Go, and a lot of the ecosystem around Prometheus is written in Go, which means that it's actually quite readable, and you can dive in and look at the source code and kind of work out what's going on. One of the reasons that we switched to Prometheus from our previous monitoring solution was because of the service discovery facilities in Prometheus. And what that means is that you don't need to configure every endpoint that you want to monitor explicitly. Prometheus can go out and find things to monitor. And it's got built-in service discovery for most of the big cloud providers like Google and AWS and Azure. And then it's also got extension points. So if it can't already do the sort of service discovery you want, it has something called file-based service discovery. So you can just have an external process writing a file in a particular format, and Prometheus will read that file every time it changes to find out what you want it to monitor. It does metrics collection. So it's basically got a built-in crawler that will scrape metrics from multiple targets. It's got a built-in time series database, so it's got metric storage, and it's got a rules engine for computing new metrics from existing metrics and for generating alerts. So what does it look like? It has a microservice architecture, so there are lots of components to Prometheus. This diagram's from their website, and it's a bit like a map of the London Underground, so it's not completely truthful. It's more sort of representative of what's happening. So the Prometheus server contains basically they've called it retrieval on here for retrieving metrics from the things you're monitoring, the time series database, which is persisting to hard disk, an HTTP server with which other services can interact with your Prometheus server, the Prometheus Web UI, which is on the right-hand side here, is actually part of the main server normally. It has an API, so you can get data out of Prometheus through an API. Something that's not shown on here is it also has external syncs. So it is possible to persist the time series data to an external database like a Postgres database or something like InfluxDB. It's got various different plugins for doing that. On the right-hand side, data visualization, there's Grafana. Grafana is a third-party application for doing dashboards, and Grafana has an integration to pull data from the Prometheus time series database. The alerting, I mentioned the rules engine for generating alerts, that runs inside the Prometheus server, but if Prometheus fires an alert, it actually connects to another service called the Alert Manager. And it's the job of the Alert Manager to deduplicate alerts and to make sure that they get sent wherever they're configured to go, like PagerDuty or email or Slack or whatever. On the left-hand side of the picture, we've got a thing called the Prometheus Push Gateway. Because Prometheus uses a pull mechanism to pull, it fetches metrics from an HTTP endpoint. If you've got something like a cron job or a batch job, Prometheus can't pull from it because it's only running for a short time. So the push gateway sits there permanently, and your cron job pushes metrics to the push gateway, and then Prometheus scrapes those metrics from the push gateway. The thing that we're going to talk about today is the thing I've left to last, which is the bottom left-hand corner. Prometheus targets jobs and exporters. So we're going to be looking at how do we write a custom exporter for Prometheus Metrics for our application. And that's where our focus is going to be today. Okay. There are lots of Prometheus exporters already out there, and this is just a very small fraction of them. So the node exporters for Windows and Linux are for collecting operating system level statistics, like free memory on the operating system, 1 minute and 5 minute load averages, what services are running, that sort of thing. The black box exporter is basically something that you configure to ping websites, or actually do an ICMP ping of network endpoints, and it can then measure like request latency. So this is if you didn't have a metrics endpoint in your application, you could configure the black box exporter to probe your application every so often, and then Prometheus can scrape the black box exporter to find out whether or not your application's up and what the latency is. And then it's got various exporters that integrate with other bits of software. And what those exporters do is they provide an HTTP endpoint for Prometheus to crawl. And when Prometheus requests the metrics, they will fetch the metrics from the source system, translate them into a format that Prometheus can understand, and re-export them to Prometheus. And there are literally hundreds of exporters. Okay, so all of the data in Prometheus are basically time series, and time series are defined by the name. In this example, it's called HTTP requests total, but there's actually a unique time series in the database for every metric name and key value pair, every label and value pair. So for each HTTP method and each path, there'll be a metric in the time series database. And we'll see this in example when we start, in practice, when we start using the client library. The other thing that's important to know is what sort of metrics does Prometheus Export support. And basically counters, gauges, histograms, and summaries. The simplest thing is a counter. A counter is just a metric that always goes up. And all you can do to a counter is increment it or reset it to 0. You would use counters for things like request counts and error counts. How many requests, and every time you handle a request, you increment the counter. A gauge is like a counter, but it can go down as well as up. And you could use a gauge for measuring things like temperature or free memory or number of requests in flight, because they're things that can go up and down. A histogram is basically a bar chart, and you would use a histogram for things like request duration. And basically, when you define a histogram, you define a number of buckets, and then what it does is it counts how many things fall into each bucket over time. So if it was a request duration histogram, you'd have a bucket for requests that were served in under a millisecond, a bucket for requests that were served in under 10 milliseconds, etc., up to infinity, actually. It would then basically increment counters appropriately for each bucket. A summary is a bit more complicated than a histogram. A summary basically computes windowed quantiles. So like a histogram, you have to define the buckets for a summary. And a simple one would be a quartile, where you have a value for 0, a value for 0.25, a value for 0.5, a value for 0.75, and a value for 1. It uses something called a streaming phi quartile. Do people already know what this is, or shall I carry on and try to explain what this is? Okay, so basically phi of 0 is the minimum value that's been observed in that window. Phi of 1 is the maximum value. Phi of 0.5 is saying that 50% of the observations are less than that value. So phi of 1, 100% of observations are less than that value. 5, 0.75, 75%. I mean, the common ones are quartiles and percentiles. So percentiles would have 100 buckets, and if you're in the 99th percentile, you're in the top 1% of the values, and they give different information from a histogram. They give similar information to a histogram. I haven't used summaries, but if you're interested in percentiles, that's the one you want. A note on counters. When we talked about what metrics we wanted to collect, what we want to observe, it was things like request rates. And obviously, if we know the value of a counter over time, we can use two values over time to compute a rate. So if we know how many requests are handled at time A and how many requests have been handled by time B, we can work out the request rate, which is the thing that we're actually more interested in. We'll have an example of that in a minute. So the exposition format is a simple text format. And there are basically two header lines, one with a help tag, which is just the name of the metric, and a human readable string describing the metric. And then a type tag with the metric name and the metric type. And you can see here that Prometheus is representing a quartile as effectively basically a number of labels for each quartile. So this is actually a quartile rather than a generic quantile, and also got the sum and count. And for histograms as well, it'll have a label for each bucket and a sum and count, so you can compute the mean. And you could add Prometheus Metrics to your application simply by implementing an HTTP endpoint that presented data in this format, and then Prometheus would be able to fetch those metrics from your application. What the Go library that I'm going to show you soon, what that does is it makes it easy to do that for Go programs. Possibly, I mean, has anybody not seen this? This is the default Prometheus Web Interface. You could probably zoom in a bit. And this is not how you are normally expected to interact with Prometheus. You would normally use an add-on tool like Grafana to draw pretty dashboards. But if you're debugging or just want to explore what's in the database, this interface is quite nice, and we can have a look at one of the sort of built-in Go metrics, and that's basically pulling in that metric for all the label pairs that there are, and we can look at it over time by going to the graph. I mean, I don't expect any of these metrics to be very exciting because there's not a lot going on in the things that are being monitored. But yeah, right. Okay, so this is the whole point of the talk today, the Prometheus Go Client. There are like two halves to this client. There's one part, if you're a consumer of the Prometheus API, you can issue basically Prometheus PromQL requests against the time series database using this client. And you can also use it to instrument your application code. And it's this second thing that we're going to be looking at today. So here is our first code example. And this is straight from the Prometheus documentation, actually, from the Go Client docs. And this is basically instrumenting a Go program. This Go program doesn't do anything other than run a metrics endpoint for Prometheus to crawl, so it's not a very interesting example. But the key things are we're using the PromHTTP package, and it has an HTTP handler called promHTTP.handler, and all we're doing is using the default HTTP mux and configuring a handler for a /metrics endpoint. And let's go and have a look at what that looks like. So inside here, we have all the targets, and example 1, if we just open in the new tab. So this is the metrics that we get from that tiny HTTP server, and they are mostly metrics about the Go runtime. And we haven't had to do very much work at all to immediately be able to monitor the Go runtime of that little web server. So garbage collection, free memory, these things at the bottom are the HTTP handler monitoring itself. So there have been, since I started this example running, there have been 199 requests to the metrics handler, and they've all returned status 200. Okay. Yeah, and that's all just that's all just out of the box with very little effort on our part. What if we want to add a custom counter? So this could be a counter for something sort of internal to our application. So I've added the Prometheus package, and I've defined foo counter as Prometheus.new counter, and that takes some options, name and help, and it's pretty obvious how that's going to translate into the text exposition format. Not much going on there. What do we have to do? So I've added an init function that is going to register the counter with the Prometheus Registry. So the Prometheus library has a default registry. A registry is basically a register of metrics. The default registry is kind of similar to the default HTTP mux in the HTTP library. There's a default registry in the Prometheus library. So we create our counter, we register it. The foo function is not doing anything interesting, it's just incrementing the counter. And then in our main routine, we've just got a go routine that's going to increment that counter every second, and then we set up our metrics handler. What does that look like? That is example 2. Okay, so it's right at the top, foo total. It's been called, you can see how long this program's been running. It's been called about 3,000 times. Right. The next example is of using automatic registration. It's a bit tedious having to create a counter, then call must register. So they've provided this promauto package, and this code is exactly the same as last time, except instead of Prometheus.new counter, I'm calling promauto.new counter, and this creates the counter and then basically calls must register on the default registry. So that saves us a little bit of code, and other than that, this is.
Do you want to not register it?
Right. So the default registry has all of the Go runtime stats already registered. So if you wanted to expose metrics without exposing the Go runtime metrics, you might want your own registry.
And you can then give each registry a different HTTP endpoint to render.
Yeah. And if you're using the push gateway, you might have your own registry that doesn't have all of the Go data in it. Okay, so how do we add labels to our metrics? And basically, we call new counter vec instead of new counter. And the first argument to that is exactly the same as the argument to new counter, but the second argument is a slice of strings, which are the label names. In this case, I've just got one label called name. And this time my foo function is selecting a random name. And when I increment the counter, I call counter with, and I pass it a label structure. And and that will set the name label and then increment the counter for that name. I mean, the sort of realistic examples of this might be if you're monitoring an HTTP server, you might have a different counter for every handler, in which case you'd have the handler name as a label, or you might have the HTTP status as a label.
So you've only got 4 minutes left.
4 minutes of battery.
Yeah.
Oh, is this power strip on? Because there's no. It might be that the power supply is dead, or it might be that yeah.
It might be better if you turn the switch on.
Ah, right. Thank you. Okay. Thank you for noticing that. Okay. Yeah. Okay, so we haven't monitored anything interesting yet. What about a function that might fail? So this version of foo is going to take up to 1.5 seconds to run, and 10% of the time it's going to return an error. How are we going to monitor that? And this is basically just a little acronym to remember interesting things. It's actually 3 of the 4 golden metrics from an earlier slide, but request rate, error rate, and duration or latency. So for our function foo, it's going to be interesting to know to measure the error rate and request rate, and to know how long each request is taking. And how do we do that? So we define a counter for the total number of times it's been called, and another counter for the number of times it's returned an error. And then we're defining a histogram for the request duration. And I've defined the buckets here, going up to 5 seconds, all the way down to 1,000th of a second. And yeah, there'll basically be a label for each bucket coming out at the end. And I've written a little wrapper function, which is the sort of public interface to my foo function, and this basically increments the counter, records the start time, calls the function that we're wrapping, increments the error counter if it needs to, and then adds an observation of the duration of that call, and then it just propagates the return value from the foo function. So I mostly work in Clojure, which is a dynamic language, and in a dynamic language you can actually write generic functions for wrapping other functions without having to worry about the argument types and return types, and obviously that's a bit more difficult in Go, so we have to work a little bit harder, but not too hard. I suppose we could have a look at this. I don't remember what example I'm up to. Does anyone remember what example I'm up to?
Done 1 and 2.
I know, but I skipped 3.
We don't know what you skipped.
Yeah. Oh, we'll have a look at example 4 and see which one that is. 1, 2, 3, 4. So, 4. Oh, that was a lucky guess. So the top metrics there are the histogram, the foo duration, seconds, and it's worth noticing that the histogram buckets are defined as all the things less than or equal to some value, so it's a cumulative histogram, and you'd have to do a subtraction if you wanted to print the histogram of how many things are in each bucket. We also get the sum and count, so we can very easily compute the mean, and then we've got the error counter and the total request counter. And we can see immediately that is about 10%, which is what we expect because it was erroring 10% of the time if my code wasn't buggy. So recording rules are basically, we're now switching back to the Prometheus server. This is part of the server configuration. And this is what I was saying when Prometheus has a rules engine for deriving new metrics from existing metrics. These expressions are PromQL expressions, and because these rules say record, they are going to record a new metric. So I'm recording a new metric called foo request rate, which is basically the requests per second averaged over 1 minute. I've done a similar thing for the error rate, and then I've computed sort of point in time error percent, and I've computed the mean request duration. And if we go to Prometheus, we can actually, first of all, if we go to status, we can see the rules that are installed in the server. And it's telling us when it was last calculated and how long it took to evaluate that rule. Alerting rules look similar, but instead of record, they say alert, and the expression would be a Boolean expression to say fire this alert if this expression returns a true value. We don't have any alerts configured. So foo error rate we can look at. It's a bit less than I was expecting, but if we look at a graph, it's a bit all over the place. But it should be about 10% on average. You have to be a little bit careful with statistics, as you probably know. So things like how often is Prometheus scraping the metric? How many observations does the metric does it have in the period over which you're trying to compute the average? That can affect it, and you can get strange results if you're not careful. If you're looking at small numbers of samples over and dividing by small numbers, but yeah, okay. Derived metrics. Okay, this interface isn't very good at displaying histograms. You would really want some different software for that. So, foo duration seconds, is that the mean seconds bucket? I think that's the one. So all you're getting is a line for each bucket, which is not very interesting. It's not, but if you used Grafana, you could actually plot this as a bar chart. Okay. Right. We're now coming on to look at HTTP, and the way we add. So I said earlier about dynamic languages, it's very easy to wrap functions. With HTTP handlers, because an HTTP handler is a particular type in Go, we can write middleware that wraps HTTP handlers and changes their behavior. HTTP middleware is simply a function that takes an HTTP handler and returns a new handler, possibly with modified behavior. And it can be used to add authentication, logging, or instrumentation to an HTTP handler. And it's instrumentation we're doing today. The From HTTP package comes with a bunch of middlewares that you can wrap around your HTTP handlers. I think that they're fairly sort of obvious in their meaning from the names. The in-flight handlers is a gauge that's counting how many requests are being handled right now, whereas the counter is how many requests are handled altogether. What does one of those middlewares look like? This is straight from the source code. So in order to instrument the in-flight request count, we pass a gauge. So we have to create the gauge where we're going to record this metric. We pass that into the middleware function, and we pass next is our handler that we're wrapping. And that returns a new HTTP handler, which simply implements the counter defers a decrement of the counter, so it runs when this function returns, and then calls the HTTP handler. Some of the other ones are more complicated, but I thought I'd just keep things simple for the talk. So what do? We define our gauge, we define our counter, and we define our histogram for the request duration. What's interesting here, the counter and the histogram are interesting because they both have code and method, which those two labels have meaning to the Prom-HTTP library. The code is the HTTP response code, and the method is the HTTP method. The bottom one, where we've got handler as well, we have to do some work to set the handler label, but the HTTP library will take care of recording the code and method labels against the right metrics. So now we get a bit hairy because we have to chain together the middleware. So we've got a hello world handler, which is one of the simplest handlers you could have, and we've got a Brexit version, a goodbye world. And what we do is we construct a chain of middlewares wrapping our handler. And this is the trickiest code in the talk, and it's easiest to read it from the inside out. So if we just look at the hello chain and sort of look at this bit here, so we're passing in our counter and our hello handler, and we're wrapping that in instrument handler counter. That's returning a new handler. And we are then wrapping that in instrument handler duration. So that's a second argument to instrument handler duration. We'll come back to this must curry with. We'll come back to that in a second. And then finally, we're wrapping that handler with the instrument handler in flight. So what does must curry with? So duration is a Prometheus histogram that's defined to have three labels: the handler, the method, and the status code. When we curry it with a handler label, we turn it from a handler we turn it from a metric that needs three labels to a metric that needs two labels. And the funny name, is everybody familiar with the idea of currying, the sort of derivation of it? So it's basically, currying is a way of taking a function that takes sort of n arguments into a function that takes n minus 1 arguments by creating a function that basically sets one of the arguments. And that's what we're doing with the labels. We're taking a metric of 3 labels and turning it into a metric of 2 labels. And we have to do that because the handler duration middleware only understands the code and method labels. Any other labels we have to deal with ourselves. The goodbye chain is exactly the same, except that it's wrapping the goodbye handler and it's setting a different label. This is possibly my, where are we? Lost my mouse. This is possibly my last example, but
did you write the curry function yourself?
The must curry with is part of the Prometheus library.
All right.
So yeah, that's built in. So it's actually a method on the duration metric. Okay, so what I forgot what I've called my handlers. Does anyone remember? In-flight gate. Oh, okay. There's something else I can mention on this page is that I've added a namespace argument to the options for these metrics, and basically the Prometheus library, you can have a namespace, a subsystem, and a metric name, and they all get joined together with an underscore to form the metric name of the metric that's going to be exported. So when we look at Prometheus to look up these metrics, there'll be a metric called myHTTP_requests_total. And it's just a way of grouping together sets of metrics. And that is, the reason I did it was so we could find them here fairly easily. You can execute in flight. There's not a lot happening on this server. But basically there are requests firing against the server, but they're being handled so quickly that I think my guess is that by luck it's never actually observed them in flight. If we look at...
Slow your handle down.
Yeah, if we look at...
Maybe not trying to catch something like that would probably make a better demo.
Yeah, I mean...
Good excuse for just having a flat line. It's so fast we can't measure.
Yeah, but if this is request total, so you can see it has been handling requests as I've been talking.
Run something else on your laptop.
Yeah. Okay.
When I was reading the documentation about naming things, which is obviously tricky, I couldn't work out whether or not they were trying to hint that subsystem and namespace was something they wanted to get rid of. In favour of just giving it a name.
Yeah. Yeah, I don't know. I haven't read deeply enough to know what their intent is.
Yeah, the namespace doesn't actually seem very useful, does it?
No, I could just have put a prefix on the metric name. Yeah. Yeah. I mean, if you dig through their source code, there might be examples where it looks more useful.
Also, it's a bit magic because it must put an underscore in.
Yeah, exactly. Yeah. Okay, so I think my final slide was really for the people who came to last month's talk to look at how might we instrument a Go Swagger application. And the answer is that the server that Go Swagger generates has an extension point where it's called setup global middleware. So that is where we could set up our metrics middleware for a Go Swagger application. The question that's more difficult to answer is where do you configure the HTTP server to serve the metrics? Because you probably don't want to add /metrics to your Swagger specification and have it as part of your public API. You probably want to be running another HTTP server on a different port to serve the metrics away from your public API. And there's a thread on GitHub where there's some discussion about this, but it wasn't completely clear to me where the code to start and shut down your second web server would go inside the generated code.
That's why you shouldn't do it. Sorry. Because we're using this and we are not exposing that.
Right.
Because why would you? It's not for the consumers of it. It's for us.
Yeah, exactly. But you do need to expose your metrics for you to scrape.
But I don't need to put it in.
Agreed. Yeah, agreed.
How does it integrate with Go Swagger?
Yeah.
It doesn't need to.
Well, it lives inside the generated application.
Yeah.
So you need some sort of custom startup to start your second.
We have it separate. So.
Yeah. Okay. That's all from me. I mean, if you're not tired of listening, I can show you some real-world examples of things like the push gateway and
Show us some.
yeah. So yeah, the slides. If you went to my website, there's a link to GitHub, and on GitHub there's a GoTalks repository if you want the slides and all the example code. The code I'm about to show you is Metail code,
Maybe you should all sign disclosure.
no, it's not. There's nothing confidential in here.
Where's the enclosure? We don't want to understand that.
Yeah, it's confidential by default.
Prometheus utils, internal package. So this is the core functionality of basically a cron job that runs every 4 hours or something. and it's an example of pushing metrics into the push gateway. So what this cron job is doing is it's looking in EC2, listing all of the snapshots we have of all volumes, grouping those snapshots by volume, and looking at the creation time of the most recent snapshot. And this is basically monitoring that our backups are happening when we think they should be. And this is an example of where we're using a custom registry. So we are making a Prometheus registry. We're computing a gauge to record the backup start time. We are registering the start time metric in our registry. We are then getting the latest snapshots in a given EC2 region. And basically for each snapshot, we are working out what labels to stamp on that metric, and setting the start time as just a Unix epoch timestamp. And then we're returning the registry. So that's like that's a short-lived registry with the metrics from the observations collected by this cron job when it runs. We then call the push metrics function, which is the bottom of the screen, and the URL is the URL of our push gateway, and we basically make a new pusher that's going to push to the push gateway. The job is just the name of the job, which is just a string for our benefit. I think I've called it EC2 snapshot monitor. We then set the gatherer, and the Prometheus registry implements a gatherer interface, so we just give it the registry, and then we call pusher.add, which will connect to the push gateway and send those metrics down the push gateway API. And then our Prometheus server is crawling those metrics from the push gateway, and it's got some alerts defined that say, if you haven't seen a backup for these important volumes in the last 24 hours, send us a Slack message. So that's one of the few pieces of Go I've got in production at Metail. The other example I could show you is a bit more complicated. In fact, let's see where we are. So I don't know what state this is in. So what this is a Prometheus exporter for CloudWatch metrics, and there are already two. There's already an official CloudWatch metrics exporter written in Java, and there's an unofficial port written in Go, but neither of them give you the neither of them give you the tags from the CloudWatch metrics. So one of the use cases we had is we actually want to add tags onto our metrics. So all of our AWS resources have a team tag, which is so you know whose fault it is when it goes wrong. And I wanted to use the team tags to route the alerts to the team who need to take action. In the end, I ended up not running this code for very long. I switched back to the Java exporter because I didn't want to burden Metail with maintaining another big Go program I'd written. So they're just running. We're not actually making do without the would be nice tags on our metrics. So just need to find where I've put the interesting bits of code.
Does Prometheus come with default integrations with things like Kubernetes?
It does.
CD, that kind of stuff?
It has something called Discovery, and it also has collectors. So it definitely has service discovery for things like Kubernetes. But I don't know what it's got in terms of collecting metrics from a Kubernetes cluster. But if you go to the website and look at something somewhere, I don't know where.
It's enough to know that they're
Yeah. Yeah. Basically, go here and dig around. You'll find a big list of what's available.
You should get too much data. we use it in production, and we had to sort of limit the amount of data you get back there.
Right,
For
right.
every pod you get like 100, 200 metrics.
Right, okay.
Yeah.
Because we use Datadog at the moment, but sorry, Datadog,
Yeah.
as we say in the UK. Sorry, I'm Australian. But we're considering moving to Prometheus because we have issues with Datadog in China.
Yeah, I mean, I won't pretend that there aren't complexities with operating Kubernetes. So there are benefits to using a hosted solution if you can.
There are complexities with SaaS solutions in China, that's for sure.
Yeah,
So
yeah.
Probably less so with running yourself.
Yeah. This example is a bit more complicated. This is an example of writing a collector for something like a Kubernetes cluster, for example. Although this happens to be getting data from CloudWatch. But if you want to have Prometheus, so this example, we want Prometheus to fetch data from AWS CloudWatch. But CloudWatch doesn't have a metrics endpoint for Prometheus. So we implement this like mid layer, which is called a Prometheus collector. And Prometheus goes to our collector and says, give me the metrics. And our collector goes off to CloudWatch and fetches the values and spits them out in the right format. But the Go library has some functionality to make that reasonably easy to do. And what you have to do is implement a collector interface. So I've got this thing called ELB collector, because it's collecting ELB metrics from CloudWatch. ELB is the load balancer. So we're collecting load balancer metrics, which will give us actually very similar things to what we could have got directly from Prometheus if we had a Go application instead of using an AWS load balancer. But the two methods that we have to implement are describe and collect. And you can see the function signatures there. So describe is, what's that doing? It's being passed a channel down which we have to spit a bunch of Prometheus description objects. And that's basically list metrics. That's saying what metrics are available from this collector. And the second thing is the collect method, which is given a channel down which we have to spit Prometheus metrics. And you can probably see where we're doing this. So we're actually just, in this little chunk of code here, we're just producing a constant metric with the appropriate metric name and labels, and putting that constant metric down on our channel. And then we're looping over some more things and producing more constant metrics that are being spat down our channel. So there's nothing too difficult there. The rest of the code is just implementation detail. The key thing is those two methods, describe and collect. And that's basically, I think, how the sort of interface that the things like gauges and counters in Prometheus must implement, because when the HTTP exporter wants to get the metrics from a registry, it's going to call collect on all of the things registered in that registry, and then convert them to the text format to output. Okay, that's me done. So thank you for listening. Does anybody have any questions? Okay, cool. Thank you.
I've got a question. With the push gateway, I have a vague recollection that you weren't supposed to use it for one particular task. Can you remember what it was?
I don't know.
No. Because I remember because I implemented one and I checked and I thought, no, I'm not using it for the task you're not supposed to use it for, but I can't remember what it was now.
Right, I don't know. I mean, the one thing I would say that you have to be careful with is basically alerting on absence of data is a bit tedious to configure, but needs to be done, particularly if you're using auto-discovery. So we're using auto-discovery to find EC2 nodes. And if a node goes down, we get an alert saying node down. Then the auto-discovery notices the node's gone and stops it being monitored. So we've had that one opportunity to see the alert that our service is down. So you also need an absence alert. And the thing about the push gateway is that the push gateway persists the metrics. So you send metrics and they'll stay there until you shut down the push gateway. So if your job doesn't run again, the metric's still there being scraped and Prometheus is seeing an old value. So you do need to be checking for freshness. You need to be aware.
So I suppose you need a kind of a scrape counter or something to
Or
say.
the epoch time of the last time you sent.
Well, you might want to alert on the timestamp of the metric rather than the value of the metric.
Epoch counts like counting ones or counting.
Yeah. It's probably there are probably mitigation techniques in the documentation, but it's just something to be aware of.
So one of the things I haven't had a lot of experience, but we did start using it whereas before, and the histogram thing, or trying to do timing, because what I'd used before was kind of effectively every single measurement of time was, we collected it and then we could kind of go, oh look, there's the chart. As soon as you go to Prometheus, as soon as you go to this pill model, then it's more difficult. And with the histogram for how long did it take to do something, we put in a histogram, but you just have to kind of guess how long is it going to take, what bucket sizes. So I think I implemented a function that kind of paired them up. So I'd always have a histogram and a gauge. This might be something that I would delete, once I understood more about software. But you start off with a histogram and a gauge, so that the gauge is, this is how long it took last time it ran, so that you can at least say, oh yeah, that's n milliseconds, because inevitably you'd go, oh right, okay, I have no idea what the histogram is showing me, because it's not the numbers I expect, because I've got the buckets wrong. So I found that a useful thing. But I don't know how it would pan out over time, because I wasn't there for Interesting.
Yeah, I mean, for some of our metrics, we are collecting the value and the observation time as an explicit metric, and then we're alerting if the thing hasn't been observed in a expected time frame. One of the other nice things I like about the Prometheus alerts is you can add, as well as the expression, you can add for, as in FOR, and a time expression. So you can say alert if this expression has been true for 10 minutes. So for things that come and go or just repair themselves, you don't necessarily want to be paged. You might want to add some damping there, particularly if things are flip-flopping. So then you need a detector to say it's flip-flopping, because that in itself might be a problem, but yeah.
Had any problems with memory usage? Because we've seen Prometheus go very useful.
Yes. So when I first gave a demo of Prometheus, and everybody in the room was trying to query it, it very embarrassingly died horribly on me. What was nice is by the time I got round to looking to see what had gone wrong, the AWS autoscaling had spun up a new instance and everything was fine again. But but yes, I have, and that was specifically basically a query against the time series database that was returning a lot of data. So one of the things that you can track for Linux nodes is systemd unit status, which has a metric for every systemd unit, for every possible state it might be in, with a value of 0 or 1, depending on whether or not it's in that state. So there are maybe 6 metrics per systemd service and 50 or 100 services per node, times 50 or 100 nodes, and when 2 or 3 people do that query, it certainly killed Prometheus on the instance size it was running on. But, yeah.
Do you just run it with a default time series database that is built in, or do you use something else behind it?
We are just using the default, and at the moment I've made the decision not to try to persist metrics beyond the lifetime of the EC2 instance, because our primary use case is for alerting about current issues. We're not trying to collect historical data through the time series database. But if we wanted to, we have a couple of options. We could either use a persistent DBS volume, but that makes auto-scaling harder, because who owns the volume? Or we could add a sync to a persistent time series database, but we haven't yet needed to.
Mhm.
So I've just kept things as simple as I could for now.
When does it clean up, or have you hit the limit as to
Um,
start to leak long?
There's a default, I think, of either 15 or 30 days. So I haven't looked in detail at the implementation, but I think the time series are stored in different files over time, so it can clean up simply by deleting the old files. And that's all automated within Prometheus, and it's configurable how long to keep the time series.
You haven't had any problems?
Not yet, but it's never been running for more than a month. So, because we redeploy all our servers at least once a month, so yeah.
You guys are running it with Kubernetes.
Okay, well, thank you all for your attention, and see you next time.
Excellent.